So 4.3, distinguishable permutations. Explore, how many three-letter permutations can you make with the letters in the word math? All right, so now we are going to elect members of our mathlete group. So here's the options. For president, vice president, secretary, social convener, am I saying that right? Or head tutor, we've got Marina, Julius Tuba, Julius Rara, Curtis, and Morgan. You guys are our new mathlete team. So how many different ways could we select them for these positions? Part B, now let's say that we're only going to vote for the president, vice president, treasurer, and secretary. So now we're only filling 4 positions. So we're going to use our NPR. So N in this case is 5 because we've got 5 people to choose from. And R is 4 because we have 4 positions to fill. So this is going to be 5 factorial over 5 minus 4 factorial, or 5 factorial over 1 factorial, which is 5 factorial. And that equals 120. Good. Now, part 2. Let's say you're only going to vote for president, vice president, and treasurer. So now you're only voting for 3 spots. Good. We're only choosing 3. I like that. You said 5 pick 3? Good. Oh, cool. So this is going to be 5 factorial over 5 factorial minus, sorry, not 5 factorial, 5 minus 3 factorial, which is 5 factorial over 2 factorial. And 5 we can break down into 5, 4, 3, 2, 1. And 2 factorial is 2 times 1. So we'll notice that those cancel. And you're left with 5 times 4 times 3, which is 60. Then part 3, we're only going to vote for the president. So there are going to be 5 people for how many positions? 1. So 5 factorial over 5 minus 1 factorial, which is 5, 4, 3, 2, 1, over 4 factorial. So those will cancel, and you'll be left with 5 different ways. All right, so Haley claims that the expression 5 factorial over 1 factorial represents a number of ways I can fill out my ballot for president, vice president, treasurer, and secretary. Do you agree? You should agree because if you plug our numbers into our formula, you get 5 factorial over 1 factorial. So NPR is our notation used to represent the number of permutations that can be made from a set of objects where only R of them are picked. And R has to be between 0 and N. Notes. So we have this formula that can be used with our NPR. So that means we have n elements. We're going to pick R of them. And that will give us n factorial over n minus r factorial. So example 1, Cody downloaded 10 new songs from iTunes. He wanted to create a playlist using 6 of these arranged in any order. How many different 6-song playlists can be created from his new downloaded songs? So is there a definite order when you're talking about songs? In any order, but there is an order. So that means we do have to use permutations. So we can do 10p6. So 10p6 is 10 factorial over 4 factorial, which in your calculator is 151,200? Okay. Now you try this next one. Let's say he actually wants 8 songs because it was too short. So now he's still got 10 songs and he's picking 8 of them. So example 2 says let's find the value of 0 factorial. Use the formula that we just learned to justify. So if we have npn, we know that that equals n factorial over n minus n factorial. Now this becomes n factorial over 0 factorial. And we know that npn equals n factorial. So in this case, 0 factorial must equal 1. So example 3 says state the values of n for which each expression are defined, where n is an element of integers. So n plus 3 factorial. Where will this have a solution? Remember that this whole thing cannot be negative and it cannot be 0. So what does n have to be in order? No. Greater than or equal to negative 3. Because 0 factorial is actually 1. How about here? What would our top have to be in order for this to be defined? N is greater than or equal to negative 2 on the bottom, I heard. Good. How about on the top? 0. Good. So remember that this is just what you'd plug into the brackets to make these not negative. So if we plug anything less than negative 2 in here, we're going to get a negative factorial, which we can't have because it's not a natural number. Example 4. Tori needs to create a password for social networking. She can use the digits from 0 to 9 and or any letters of the alphabet. The password is case sensitive, so she can use both lower and uppercase. Must be at least 5 characters to a maximum of 7 characters, and each character can be used only once. How many different passwords are there? So let's figure out all the total possible characters. How many numbers can you have? 10 numbers. How many letters can you have? 26 lowercase, 26 uppercase. So you're going to have a total of 62 total characters. So let's say that they want a 5-character password. 62 options, and we're going to pick 5 of them. A 6-character password is going to be 62, and we're picking 6. A 7-character password is 62, and we're picking 7. All right, then we have example 5. There's a used car lot. There's 7 different car models. 3 cars are red. We need to park them so that there's a red car at each end. And the third red car is in the middle. How many ways can the 7 cars be parked?